So this is an ideal gas law problem. And the key to these problems is it's all in the preparation. If you get everything set up right, the problem itself is not so difficult. So we're going to start by identifying each of these variables and what they are. So first we have 2.5 liters. So we should recognize this as a volume. So I'm going to write volume equals 2.5 liters. And next I see 1.2 atmospheres. This we should recognize as a pressure. Is a unit of pressure, 1.2 atmospheres. And this one's probably the easiest, 25 degrees Celsius, that is a temperature. And it's also important to note what they're asking for. In this case, they're asking for moles. So moles has the symbol N. So that is unknown. So we identify all the knowns and all the unknowns. Now the ideal gas law states that pressure times the volume equals the number of moles times the ideal gas constant times temperature. So we also need to know, if we go through this, if we know P, V, and T, and we're looking for N, we also must know R. And R, being a constant, is always the same value. In this case, it's 0.0821. Now, units are extremely important here. The units are 0.0821 liters times atmospheres over moles times Kelvin. Now this R is a constant, it never changes. The number itself could change if the units for it did, but these are the units we're going to use most commonly. R is like pi, this is a constant for any gas that behaves ideally. So one of the key things about these units for the preparation is we need to make sure that all of our variables match these units. In other words, volume is in liters, and that is going to have to cancel with this liters. So if they don't match, we have to make sure these all convert to match. In other words, pressure here is in atmospheres, that matches up, that's going to be okay. Temperature's in Celsius, so that's not going to cancel with Kelvin. So before I can do this problem, I have to convert my Celsius to Kelvin. And if we remember to convert to Kelvin, we simply add 273. So my temperature is 298 Kelvin. So I'm going to be using that for this problem. I'm not going to use the 25. So now I'm looking for N. So now it's just a matter of solving for N. So if I look at my equation, PV equals nRT. If I divide by RT on both sides, I get the equation N equals PV divided by RT. And now it's just a matter of plugging these numbers in. So the pressure is 1.2 atmospheres times the volume, which is 2.5 liters, divided by R, 0.0821 liter atmospheres over moles times Kelvin, times the temperature, which is 298 Kelvin. And if I look at the units here and pay attention to them, I notice that they all cancel out except for what I'm looking for. So atmospheres cancel, liters cancel, kelvins cancel, and I'm left with 1 over moles, which is just moles. And so now if I do this out mathematically, I'll get my answer. Got to be careful when you place this in your calculator. Make sure you do, if you have parentheses as an option, you're dividing by the entire denominator. A lot of people make a mistake in their calculator when they do this and get a wrong answer. So just make sure you're dividing properly using order of operation. So if you've done this properly, you should get 0.12, and we'll round 0.123 moles for N. That's your final answer. Now, it never hurts to just check this. In other words, go back. So this is 0.123 moles. According to this equation, P times V equals nRT. So if I multiply PV, 2.5 times 1.2, I get 3. So N times R times T should also give me 3. So 298 times 0.123 times 0.0821 should also give me a number very close to 3. If that works, yeah, it does. So that means I've done this correctly, assuming all my units are right. So that is how you do an ideal gas law problem. So until next time, I'm Derek Genova, and have a delightful day.